Yeah, I'll do the repair for this Pioneer SX-680s today. The previous owner stay. The unit is power on, but no sound output. It doesn't matter who say this unit is power on before. I will not direct connect the unit to the power without any checking, because even though their previous owner or someone did power on this service before I received it, but you may have some other like a shipment impact or something can make extra damage to that. So before we actually power on the unit, I have to do some checking, and I have a procedure to detect what is the point I can connect this unit to the power on. First of all, I'll do a visual check for the major section of the amplifier, like the power supply and the power output unit, to see if any obvious burning or some of the damage we can visualize. Let's check the power unit. This is the main transformer and the rectifier, and there is a two big field capacitor. I don't see any obvious burning part over here. Let's move to the power output. This amplifier using two SDK0039 hybrid IC to do the power output. It is the same transistor inside the IC, so it pretty much have the same performance and the same quality of the sound. Yeah, I don't see a major damage or burning in the power output unit either. Let's check the back of the circuit board. This section is the power unit. It looks okay to me, and it goes through everywhere. It doesn't see any obvious problem we needed to fix immediately. The next step is check the connectivity from the power cord to the unit. I connect my ohm meter to the power cord connection, and let's turn on the power switch. Yeah, we can see there is connectivity to that. That means the power switch, the power cord, and the main power fuse are okay. So the next step, we're gonna check to see do we have any like short circuit or something can cause major big current in the unit before we power it up. Let's take a look at the diagram of this unit. Because we already tested the connectivity from the power cord to the inside of the unit, so we can sure the fuse and the power switch is okay. So next step is we need to confirm we don't have major short circuit before we power on this unit. The most important one is the number one. It's the main power output. This is to the power IC. It have positive 30 volt and negative 30 volt. So if we check here, we don't have major short circuit, then most likely the power IC is okay. And the second one is that there is a 45 volt over here. And if we check this 45 volt to see is the short circuit over here. The third one is the 13.6 volt. I believe this section is provide voltage to the tuner or some other small current unit. So if this 3 point we don't have major short circuit, then we're gonna go to the power IC to see is there any problem over there. If everything's fine, we will go ahead to put it in dimble to do the next step. The SX-680 is using a hybrid IC for the power output. It's very famous at the 70. Initially made by Sanyo. And they have a variation of the IC at that time. The STK is the most famous one. And this unit used 2 pieces of the STK 0039. 0039 is similar to like 30 watt to 39 watt, that kind of range. As we can see inside this IC, this is the one IC, and this is another IC. Inside this IC, actually it is just some of the transistor or some small parts. They put it in one of the container, so it's easy to produce. It only has 6 pin connect to the outside of the circuit board, so it's much easy to assemble this unit. It may be they cut a lot of costs for the manufacturer. And for the power testing, majority we are testing the pin 9 and the pin 2. This 2 is actually connect to the main power output, 30 volt and negative 30 volt. And also we check the 8A and 3 for the output. This is the output pin. So you check this thing to see they have any short circuit to the ground. If this 4 pin have no major problem, that means we don't have like a major short circuit to the unit. Even though the small piece in front of them, anyone have some kind of short circuit, it doesn't cause a lot of problem because they have like usually they have some resistor to limit the power to the small unit, small transistor or the other driver. Let's check the power supply. I marked the number 1, 2, 3 match to the power supply we showed just now in the diagram. The first section is the main power supply filter cap. This is the ground. So we are sure the ground is connected. And this one is the positive. Yeah, we see the cap is charging. There's no short circuit. And go to the other side. Yeah, we can see the other cap is also charging. There's no major short circuit here. And because this capacitor is direct connect to the power IC, majority of the time, most of the time we can say the power IC have no major short circuit. It may be broken, it may be working, who knows, but there's not major short circuit for the power IC. Let's check the number 2. It's the 45 volt output. Yeah, we don't see short circuit here, so most likely this output is okay. Let's move to the number 3. It's the 13 volt output for the tunnel or somewhere. There's a transistor over here. This transistor is the output of the 13 volt. Yeah, it should be good. We don't see short circuit here. So after this test, we are okay to see the power section. We don't have major short circuit. Let's see the power IC to see if that possible have any short circuit inside. We know the number 9, this is main power input, and the number 2 is the main power input. Yeah, we don't see short circuit. Right now it's charging the main power cap, and the number 3 and the number 8 is the main power output pin. It's also not any short circuit to the ground. The number 1 and the number 10, it is the signal input. This 2 is not big problem for the power up. Okay, now we roughly go through the power section and the main power output. So I also check the other one, the other IC also. Everything look fine. So in this case, I will say we can just go to the next section, next step, to connect the unit to the gimbal to see how it look like. I have connect the unit to the gimbal. This is the power cord, and I have a 45 watt light bulb to limit it, the power to the current can flow to the amplifier. If we have short circuit, because the resistance of the gimbal, it can drop the voltage a lot, so we can protect the major part in the amplifier. Let's power it up to see what it looks like. Yeah, we do see the gimbal light up in the initial when we push the power button. That's because the power charged the main cap of the power supply. After the power supply charged the cap, and then the current will drop immediately after the cap charge. Let's try it again. Yeah, we can see the gimbal is barely light up. This is the idle current of the unit, or we can say it is a base. We call it base current. With the gimbal connected, I will go ahead to try to see what is the voltage in the power supply section and the power amplifier section. Turn on the power. The gimbal is still working good. Let's check the main power output. This is the negative 30 volt. With the gimbal in the idle, it shows 29 volt, 29.5. Let's see the positive. Yes, positive and the negative both okay. Let's go for the section 2 to see that voltage, how the voltage look like. Yeah, this guy look like we got nothing. Maybe some problem here. We take a look at later. And see this one. We got 14 volt. This is the input. This is output. So most likely the 13 volts good, but the 45 volt have some problem maybe. Let's also double check the power IC to see how is the voltage doing there. We know number 2 and number 9 are the power input. We see 29, positive 29 here. And we see negative 29 here. So that means the power is reached to the power IC. And the number 3 and number 8 is the output. Number 3 and number 8 is output. We got 0 volt there. That means we don't get the higher higher DC voltage to the speaker. If we connect the speaker to that, it should be safe to connect the speaker to that. Yeah, I also double check the other side of the other channel of the IC. It's also the same. So that means the power IC, power supply, the voltage with the gimbal is okay. Next step, I'm gonna connect the power cord to the main, to the full power, to double check that it's still okay. There is 2 fuse connect to the outside 120 volt and the inside current also. This is one and the other one is over there. Before I do anything further, after I connect to the full power, I'll keep an eye on that. So if I push the power button on, nothing happen, it should be good. If something happen, I will immediately shut off the power. Let's try that. On. Yeah, we look good. The other indication is what? When we push the power button, we also see the light is on in the amplifier. Yeah, that means we can full power of this unit. Let's go ahead to double check the voltage also. We come back to here. Let's check the main power to see what the voltage is. It's a 35 volt. It looks like it's a full power now. Yeah, it both 35 volt negative and positive are okay. Yeah, I have connect my test speaker to the amplifier, to speaker 1. This is left channel, this is right channel. This thing gonna wire up to my test speaker over here. It's just two like speaker with a VU meter over there to see what the signal output to the speaker. Also, before we put the signal in, we need to turn the volume to minimum, and the input we put it into aux, and speaker we select the speaker A. Speaker A. Yeah, sure, the power is off right now. Let's put something, input some signal to see what it look like. Now I connect my scope, the lead, to the input signal, and the I'm using a signal generator to put in 1000 Hz sine wave, and this signal is connected to the signal input. Yeah, I can see the signal is on the it showed up in my scope. Let's double check that. Yeah, when I stop the signal, it stopped. When I run that, it showed up. Yeah, signal is getting into the amplifier. Let me slowly turn on the power button to see do I get any signal output. and it's output to the speaker. Yeah, I don't hear anything. Let's check the power output section. This too is the output IC. We don't get signal here, definitely. Even though in the input capacitor over here, we don't even get the signal. Without the signal get into this power output section, sure, we get no sound to hear. But we already double checked the signal is reach out to the function section, the function select switch. But in this signal path, you see this signal is come from here to the transistor 506, and then from 506 go up to this transistor 304, and after the 304 you get into the power output section. This transistor, it connect in the signal path. They connect two channels each other together. I think this should be some sort of the mute functions transistor. Some signal apply from here. It makes this thing as a switch to cut off the signal. If something going wrong over here, sure, the signal can get cut off. But first, let us check, do we have signal over here in the 506? If we have 506, and then we go ahead to check this one. Okay, let's go back to the unit. I believe it's 506 or 505. Let's see that channel here. Remember, this one is after the volume control. Right now we are in the power off, so we can just go ahead to turn around the power switch to see, do we have signal over here? Yeah, we do see the signal reach here. Reach here. The signal is reach here. So if we have signal get out from here or here after the power switch, the power on, then the signal will feed to the next step. Let's turn on the power. Double check the signal. It's over here, and we come over here to see. We do get some signal here, and we go to the C. We don't see anything out here, and we don't see anything out from here either. But we do get signal input into the B pin, but the C and E, there's nothing there. Okay, maybe something going on here. Let's check the voltage to see if that transistor working good. Okay, let me put it into the 20 volt. Let's check the voltage. In the B, 0.9. Nothing. Also nothing. Here we got no voltage at this signal transistor. I will believe there's something going on with the power supply. You remember when we double checked the power voltage at that time, we get one transistor, we don't have power output. We will go there, double check that thing. I went back to the diagram to check the power for the Q506. I found out it is a 44.8 volt from the top. the 45-volt output in this section, the 45-volt, we seen doesn't have anything come out. So we will go back to check this path to see if that transistor have problem or something going wrong in the between. Let's check this 45-volt output. This is a C. It's supposed to get the voltage from the transformer. See, we got nothing. It going down here, over connect to here, nothing, connect to here. And this is the one who have the oh yeah, we got 54 volt over here. In this diagram, we can see the C pin of this transistor is connected to the small 33 ohm resistance, and then connect to the power. Yeah, this thing's broken right now. It may be some sort of the short circuit or this broken, and then it caused this thing bend down. Let's double check the transistor to see if that transistor have problem or not. If this transistor have no problem, then we probably be able to restore this resistance to see what's gonna happen. Okay, let's power off the unit to do the testing. But because the capacitor in the power supply section is usually a big power, big capacitor. If we get something broken in the power path, the capacitor can keep the voltage in the capacitor. So before we go anything further, we need to double check that thing still have a lot of voltage over there. If it is, it might cause a problem when you touch something. Okay, let's check the yeah, we still get pretty high voltage on that thing. In this case, I'm gonna use my I got some of the 10 ohm resistance, and I got 3 of them in series. So I will use this thing to let's put in over here. Put it over here to see how is the voltage going. Okay, now we release the voltage. And the same thing you can do for the main power capacitor. Yeah, you clean up their voltage. So by that way, when you're working on the power section, you don't have the problem to the capacitor have the high voltage. It hit the transistor, it broke. It make the situation worse. Okay, now we're gonna go ahead to check the resistance. See, do we have any short circuit? Good here. Good here. This is output. This is E pin. So we can just replace this resistance. Let me double check this resistance to see what it look like. It's 33 ohms supposed to be. It got nothing here. It has to be went down. Okay? Okay, let's double check that resistor. I believe this is B. Yeah, it looks like it is a PNP. It's a NPN transistor. See, this is B, and then E and C. Go backward. It's good. So by now, I will say most likely we're gonna go ahead to replace this one. Yeah, let's put in the replacement. Now, to be a little bit conservative, I still try to go into the gimbal. Let's power it on to see. I hear the sound of the 1000 hertz from the speaker. Got the problem is the power supply problem, not the signal path. Now we come back to check the signal from that Q506. This is the B drive, the B pin. Let's turn on the. Yeah, I can see the signal. You see the power, the volume control can control the signal strength. Yeah, there is a lot of like noise over there. I'm not so crazy about that. So let's check the C pin. Yeah, we see the C pin get signal output. The C pin get signal output. Yeah, this signal gonna go all the way to the power output. And now I connect my scope to the speaker output connector. Let's check the signal to see how it's working. Yeah, we see both channels have like output, and the sound wave is pretty. Look like the amplifier is fixed. Let's try something I like the most of this 70 amplifier. That's something special here. Let's play some 70 music also.